And here we go. I'm going to put on speaker view. And here we go. It should be me. Why is it you? Well, I'll just keep talking, and the algorithm should be able to figure this out, or else I maybe just go back to gallery view. Okay. All right. Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Tuesday, September 22, 2020. I'm Dr. Bill Waller, an astronomer, science educator, and communicator, coming to you today from Rockport, Massachusetts. Today is a special day as it marks the equinox, when planet-wide the amount of daytime is equal to the amount of nighttime, 12 hours each. When the sun rises due east and when it sets due west. Here in the northern hemisphere, we are experiencing the autumnal equinox with our daytime hours decreasing, while our southern hemisphere counterparts are experiencing the spring or vernal equinox with their daytime hours increasing. Wherever you are, I hope you enjoy this special day of equilibrium in space and time. Today is also special because I have the honor of hosting Stella Kafka, Dr. Stella Kafka, Director of the American Association of Variable Star Observers, or AAVSO. Stella became director of this international organization in 2015 after having developed an impressive portfolio in astronomical research, education, and public outreach. So before I give her a hearty welcome, I also want to note that we have some other folks in the gallery, and they're all local to Cape Ann, and I look forward to any questions that they may have. But first off, a hearty welcome to you, Stella Kafka.
Thank you very much, Bill, and thank you all for tuning in. I hope you are well and safe, and thank you for joining us today. I intentionally didn't let Bill give my introduction because I have prepared an introduction for you all. May I please share my screen?
Sure, absolutely.
See if I might have permission.
Oh, I have to give you permission. Hold on. That is under security. And share screen. There you go. Okay.
Here we are.
There you go. I see it.
Power. There you go. So hi everyone, as you might or might not notice, I do have an accent. My name is Stella Kafka. I'm the Executive Director and CEO of the AAVSO, and I would like to actually tell you a little bit about my trip that got me here. Again, as I mentioned, I have an accent, so I was born and raised somewhere here in Europe, in a tiny little country that is called Greece. And actually, I was born and raised in the capital of that country, Athens. This is Athens nowadays. It's one of the biggest cities in Greece. It's about 5 million people, full of history, the cradle of Western civilization and of thought and of science. Back at the time, we were calling everything philosophy, and we're calling everything science. But this is where people, some of the first thinkers looked up in the sky and started wondering what's out there, where we are, where do we belong as a species, how did we come to be here, and what is our place in the universe. I got my bachelor's in physics from the University of Athens, and from there, are you ready? I left my tiny little corner of the world and went all the way to Indiana. Bloomington, Indiana. I am a Hoosier girl. This is where I got my PhD in astrophysics, and we can talk a little bit more about what I did there. But from there, I had a very interesting trip. Oh, there's a delay. Cool. From there, really launched myself. Oh, I'm a Bitmoji person, so you're gonna see lots of funky stuff here. From Bloomington, Indiana, where I spent 6 of the best years of my life with a PhD and a master's in astrophysics, I went all the way down to South America in Chile, where I was the site director and a fellow of the Cerro Tololo Inter-American Observatory. There, I was a director of a program. I was bringing students in Chile for scientific projects. So we're bringing students from the US, we were doing research with them in astronomy, and I was doing my own research. From there, I went to Caltech at the Spitzer Science Center, where I was working with space-based data as a Spitzer Science Center postdoctoral fellow. From there, I went to the Carnegie Institution of Washington as a NASA Astrobiology Institute fellow. I was doing my own research, working on long-term activity indicators around stars similar to ours to figure out whether they can have habitable conditions. From there, I went to the American Institute of Physics, where I was a journal manager. I was working with scientific journal, I launched a journal, Material Sciences. Are you tired yet? And from there, about 6 years ago, I came to Cambridge, Massachusetts, where I became the executive director of the American Association of Variable Star Observers. So after kind of a trip around the world, I finally landed here. What I work on is variable stars, stars whose brightness is changing with time, within time scales that we can measure with respect to stars that do not change, whose brightness are not changing with time. And this little picture is pretty much showcasing some of my research interests. This is what we call a star cluster. These are families of stars that were born together, but evolved in a different way, in different rate. For completely different reasons. These are 3 pictures together that were actually made into a movie. And if you notice, if you pay close attention, the stars in the cluster are not doing anything. But if you pay closer attention, you will see that there are a couple of stars whose brightness is changing. Can you see them? This one here. And there are a couple up here and up here. This is what we call variable stars. These are stars whose brightness is changing within timescales that we can actually observe. And you can observe them either with digital means like your DSLR camera or your CCD camera, or even with your own eyes. Actually, as a private citizen, I have a pair of binoculars where I'm doing this kind of business, visual observing. My own personal research interests are cataclysmic variables. These are pretty much 2 stars together, very, very close to each other, and they're causing lots of trouble. This is a star that has a mass of perhaps half of the mass of the sun. It's pretty much a normal, boring star. And this tiny little dot in the middle, just imagine a tiny little pin in the middle of this bright mess, is what we call a white dwarf. Now, a white dwarf is a star that has the mass of the sun squeezed to the size of the Earth. So it's a very, very dense star, gravitationally really heavy star. So because of that, it's cannibalizing its companion. So pretty much it's doing something like that. So yes, that is happening in the universe, and it's happening in a very dramatic way. The same way as when we eat very fast, a lot of food, we throw up, those stars tend to throw up. And this is what we call nova eruptions in astrophysics. And occasionally, if you burst out of eating a lot of food, you may actually burst as a star as well. So this is what we call supernovae. So I'm studying the properties of those stars, how one is eating its companion, how it's becoming a nova, how it keeps becoming a nova. And for that, I use a lot of resources. And part of the resources are telescopes. So I spend a lot of time in observing rooms like that. And I use the AAVSO itself as a resource, all the data that have been collected by our observers for decades. My very favorite site is actually this. This is at Cerro Tololo Inter-American Observatory. This is down in Chile, the night sky, looking at the center of the Milky Way galaxy. It's really bright, it's really beautiful, it's really magnificent. It helps you connect to the night sky. So this is one of my favorite pictures, that one of the views that I go back to every time I really want to ground myself and figure out where exactly I belong. Actually, from the very, very beginning of my career, I started using AAVSO data. The science that I'm doing is relevant to investigation of the history of stars, how those stars are behaving with time. And the longer baseline that I have, the better I try to understand even a snapshot of their lives and actually even predict what they're going to do next. And for that, the AAVSO has become a very, very key resource for my science, even when I was a graduate student. So in principle, I am a daughter of the AAVSO. My data for my PhD thesis, everything that I needed to have in my hands in order to complete my investigation and get my degree came from the AAVSO community. So I know how powerful this community can be. So actually, when I finally came back to Cambridge, Massachusetts, from my little little kind of bubble in Indiana, I knew I made a full circle. I just came back where I belong, to the AAVSO. So my life now, I work a lot with students. I really love mentoring students. We have a really great group of ambassadors at the AAVSO who are younger individuals who are doing either the research or they're pursuing their own projects. I work a lot with my board. It's part of strategic planning. It's part of figuring out how the AAVSO is going to serve its community as well. I spend a lot of time in front of computers. Pretty much we live in a digital world, for better or worse. We are connected all the time and we can do our work from anywhere we are. One of my favorite parts, the favorite parts of my job actually is giving talks to individuals and connecting with people, learning about the community's needs and how the AAVSO can actually build communities around the variable night sky. I cannot do that in person right now, but I'm hoping that even through digital media, Zoom, YouTube, etc., we can connect one way or another, but also play. We do lots of really cool stuff. So this is a picture of me and two of my colleagues when we went to see a really cool solar eclipse in 2017. Yes, it's us at 3 o'clock in the morning, trying to catch a bus to go somewhere that was not cloudy, long story. This is me when I took a short break when I was down in South Africa. This was a cheetah resort. This is where they were actually taking cheetah cubs that were deserted by their parents and trying to raise them and send them back to nature if it was possible. This is just goofing off in Montreal. What I really like about this picture, you cannot see very well, I am a Mac fanatic, so I have Apple products a lot, and this little laptop at the very back has a little pear instead of the apple. So I thought it was really funny. And this is me having the opportunity to watch the TESS launch. TESS is a satellite that was observing the whole sky over the time period of 2 years. A project that the AAVSO is, became very intimately connected and very close to very early in its conception. So my philosophy right now is that, I work hard, I play hard. I really, really like what I'm doing. I love the community that I am serving. And I like the fact that the AAVSO is more than just an organization building bridges between professional and amateur astronomers. It's an organization that serves a really bigger mission. This is the end of my introductions. If you want to ask any questions, Bill, please feel free, because I can keep going. I don't see any objections, so I will keep going. The nice thing about astronomy is that it speaks to something that is very fundamental in humans. From the very beginning of our existence, we're explorers. We try to actually explore the world around us and try to figure out what's going on in nature. We try to dig as deeply as we could and travel as far as we can in order to figure out how nature works, what kind of plants and animals are around us, how can we use them in terms of resources, where we belong in that kind of grand scheme of things. It's something that, and actually looking up in the sky, we try to even explore the sky with the primitive means that we had, our imagination, and then try to make philosophies and then try to actually gather data. And as time evolved, we could not actually, we reached our limits, right? So we could not just imagine, we really wanted to get more and more information. And actually this is reflected in science fiction, right? To boldly go. We always wanted to build a spacecraft and travel among stars, but we could not do that. So until we actually are able to do something like that, we're using our telescopes, our cameras to probe the universe and actually try to reveal what's going on in there. What kind of objects are there? How do they work? How did they start and where are they ending? How was our star formed? Why are there planets around it? What on earth is a planet? What is it made of? How was it formed? Why this one has atmosphere and the structure that it has? Why does it have life? How did life start here? And is life unique in the universe? At least life that the way we know it. So all those questions are being answered by astronomy, or at least we're trying to make progress to answer those questions through astrophysical investigations. And the AAVSO is an integral part of that. You see, variable stars are being used all over right now in science in order to reveal fundamental properties of stars. And I'm not going to get into details on where and why. You should invite me to give another talk on variable stars next time. But all the flavors of those stars are giving us indications on what is going on out there. So what we have is from eclipsing binaries to exoplanet transits, spotted variables, pulsating stars, supernovae, novae, gamma ray bursters, you name it is actually there. And actually what I really like about the AAVSO is that all those stars that you see in front of you are part of what we are studying as a community. AAVSO is a community of both professional and amateur astronomers. I'm going to touch upon it later. And also this kind of investigation, this kind of research is something that is being presented in scientific literature very, very frequently. So it's not just work that is being done for the sake of itself. It's work that is being done for the sake of promoting science. So the AAVSO was formed in 1911 as a community of individuals who actually, a group of amateur astronomers who were pursuing projects from the Harvard Observatory director. And since then, we really have expanded. We are an international organization. We have members and observers from more than 50 countries in the world, so a quarter of the world is participating to us. And we're all trying to understand some of the most exciting and crazy phenomena in the universe. The reason why we're doing what we're doing is because we want to enable anyone, anywhere to participate in scientific discovery through variable star astronomy. What you see here are some words that define who we are and what it is that we're doing. They're emphasizing our work. So you see, enable, we provide resources and equal opportunities. Anyone, it doesn't really matter where you come from, what your background is, what kind of accent you have, you should be able to participate in the AAVSO. Anywhere, you should have access to our resources. Our resources are open source and they're available to people all over the world. And my favorite word is participate, because you're actively engaged in the AAVSO in variable ways. So in various ways. So we are talking about a very active community, a community that is made of people from all over the world. It's a very diverse community. This translates to the AAVSO serving people with different needs, different priorities, different professional preparation, habits, cultural backgrounds, people who are united under the international umbrella of astronomy. Astronomy has no borders. We really need to keep that in mind. We have individuals who are interested in using variable star data for their research projects. We work with educators who introduce astronomy to their students. We collaborate with a very dedicated group of volunteers. And of course, we have our observers who are the heart of the organization and who acquire data through the telescopes, CCDs, or DSLR cameras, and they share the information through our databases. So this is pretty much our community. It looks like that. You can see me somewhere in here. So this is the philosophy and the heart of the AAVSO, sharing astronomical data, trying to understand some of the mysteries of the universe, building a database of knowledge and of data with people we don't know, but with people we can work with. It's very interesting. Right now, we are having a very active conversation on what the role of the AAVSO is in the future. And we hear all about these big telescopes and big missions and big surveys. And the question is whether the AAVSO observers and the AAVSO's work still has relevance. it's true that we live in a golden era of variable star astronomy. There's so many space and Earth missions that are exploring the night sky, but the only thing they're going to produce is a huge number of very interesting stars and interesting exoplanets to explore. Just targets. They're going to point to mysteries, and it's up to us to solve them. So right now, the way that research works is pretty much like that. It's a collaborative effort between citizen scientists, between professional astronomers, and between those who like to actually spend some time trying to understand different astrophysical phenomena. And this is what makes my personal job fun. This is where I feel I belong when it comes to the AAVSO and when it comes to its work. So going back to the very beginning, I started in a small country in the world, one of the 192 countries right now. I traveled half the world in order to get where I am right now. I started working with a small group of non-professional astronomers for some of my projects, not knowing that at some point I would be the head of this organization. And right now I feel very honored to be able to enable or help enable science amongst a very active, very passionate community of individuals. So I'm going to stop here and ask if there are any questions. I can keep talking, but I don't want to monopolize your time.
Are there any questions? If not, I can start the ball rolling with questions. Can you tell us a little bit about your advocacy for women in science?
What exactly do you want to know?
How you got started and where it has headed.
It's a very interesting, there's a very interesting way of phrasing this question. It's not necessarily an advocacy of women in science, it's an advocacy of we all have a place in science, and when we are all together, we do more. I do believe that inclusive and diverse citizen science workforces help maximize our efforts to understand anything pretty much in the universe. Mm-hmm. We do need all voices and we do need all thought processes. So it's not only women in science that I am advocating for, is that everyone, I believe that everyone or anyone, as per the mission of the AAVSO, that's why I really like working here, anyone should have the opportunity to get involved in scientific investigation if they want to do so. You know, we learn when we hear different, we learn from people's different experiences, let me put it this way. So excluding individuals from around the table is hurting us. It's hurting science and it's hurting us as people. So again, I would like to actually step away from the word advocacy. It's not only the fact that I am trying to promote as much as possible women in science, but I'm just trying to define a new normal. How about that?
Good, good.
I have a question for you. What effect would you say or effects is light pollution having on your organization? For example, fewer people signing up because they can't see the stars anymore. And on the other side of it, what effect is your organization having on the problem? What are you working with and for around the issue of light pollution?
I believe that Mario is much more qualified to tell you more about advocacy on light pollution because his work has been undoubtedly the most efficient that I know of. Light pollution has affected the AAVSO community in the sense, exactly the sense that you mentioned. Not many people have access to dark skies anymore. This is really unfortunate, and this is really hurtful in the sense that people connect or draw interest from personal experiences. So if we can't experience the night sky, if you can't look up and see this, the sky full of stars, how are you going to even start a thought process of, you know, trying to find your, where you belong, trying to find your roots and asking the questions, you know, well, what is out there? How did we come to be? Why are we here? How do we continue? Having said that, variable star astronomy is a differential science. So as long as you can see some stars, you can definitely do this kind of work. Just reminding you that Betelgeuse, one of the brightest stars in the night sky, became one of the biggest mysteries of last year. So it was really fun to try to acquire data, observe it, and try to explain it. And actually, you could do that from the middle of any city. And also, challenges like light pollution, climate change, or even the fact that we have individuals who don't have a lot of time in their hands. They can't afford in terms of personal time to stay out all night and take data because they have a job, they have a family, they have other obligations, is kind of pushing the AAVSO to come up with innovative new solutions that would engage people in science. We are pursuing data mining projects right now where individuals can actually use data from our database and other databases for discoveries, actually. We are providing individuals with tools that could help them reduce and analyze this kind of data. We do have a database that has 40,000 stars in it. And I can tell you that most of them really would need some attention. And we also build communities of individuals. So if you don't have access to telescope or telescope time, you can actually reach out to another colleague of yours through the AAVSO who has a lot of telescope and they don't have targets to observe and actually build a collaboration. So I'm hoping that this way, even though individuals do not have all the means to do this work, they can actually come to the AAVSO and find whatever resources they need in order to do whatever they're interested in. Mm-hmm. Light pollution is a problem though. It's a huge problem. And it's something that I'm hoping that people would appreciate a little bit more, not just quote unquote, because we can't see the night sky, but because, as Maria can tell you, it has direct repercussions on our health.
Of course.
Mental health and physical health. So it's a different subject that we can discuss at some point, yeah.
I'm depressed when I can't see the sky, so I agree. Stella, how is the AAVSO net going? Is that attracting people to observe who don't have telescopes?
It does. AAVSO net is moving forward. We are at the time of transition. So I would like to welcome you all to come to the AAVSO annual meeting in January. We're moving to CMOS cameras. We're going to learn more about CMOS. This particular year, actually, this year we started a webinar, a summer webinar. It's free for all. The last, no, there are two more that are going to happen over the last couple of weeks. It's every Saturday at 2 o'clock in the afternoon. Just register on our webpage. And this Saturday, we're going to be discussing CMOS cameras. So if you'd like to learn more, please register and participate in the conversation. So AAVSO.net is doing well. We haven't made a huge announcement trying to actually go past that transition right now.
Okay. I don't know if I can do January, but I am signed up for the November meeting.
Awesome. But we're going to have a discussion then too.
Me?
Now, there are other citizen science programs going on, such as the Zooniverse. And I was just wondering how, and well, first, if you interact with the Zooniverse, and if so, how?
We don't. It's a different form of citizen science. So you can actually think about citizens being engaged in science with different means and different platforms, right? So Zooniverse Zooniverse Galaxy Zoo came out from the SDSS, Sloan Digital Sky Survey database, right? They had lots of data in their hands. They just didn't have enough human power to actually process it, and it was recognized early on that there's no such thing as a perfect algorithm. The human eye can actually capture features in galaxy morphologies that a computer could not. So pretty much what they did was they put all the data online. They built a very nice, very easy to use piece of software around it where they would enable citizens to classify galaxies. It would be as simple as, you have a galaxy that is a spiral or a galaxy that's elliptical. It has structure, it doesn't have structure. Yes or no? Click, click, click. And actually, the model they followed was brilliant in the sense that it had manuals, it had workbooks, it had blogs, it had discussion forums. So it became a platform of interaction amongst between some professional astronomers who were involved in that particular project and the community. Now, having said that, the outcome of this particular science came as a crowdsourcing research result that was more accurate than any algorithm. The individuals who participated in that study, in that project, were not necessarily participating in the study of those objects, right? They didn't necessarily understand or participate in getting outcomes from the scientific results. The AAVSO is one step further. It's like we engage the whole community the way and in any way that they're comfortable with, not only with the process of acquiring data and analyzing data and what on earth this light curve is doing, but also with the scientific results. So if you want to actually participate in building a project with us, you can actually be part of the collaboration. It's much more engagement. It's much more being part of the project as opposed to somehow participate in a peripheral manner. Does it make sense?
Yeah, that makes sense.
So Zooniverse, Galaxy Zoo, Planet Hunters, disk detectors. I mean, the ingenious part with this platform is that it was open source, and it launched a whole bunch of citizen science projects, not only in astronomy, but in all kinds of sciences. Anywhere where data needed to be massaged or used, or actually information needed to be extracted in a fundamental way, had a similar platform. So it was a great example to follow for scientists all over the world to engage citizens in their work.
Yeah. Well, we have about 2 minutes left because
I see that.
It looks like my time limit has yet to expand with my Endicott College account. So does anybody else have any other questions for Stella? Okay, we're good. Laura, are we good? Okay.
Well, thank you very much for the opportunity.
Okay.
Hi.
Yeah. So yes, once we get an observatory built, it's a big project going on right now in Rockport. We'll have you come down for the opening.
I would love that. I would love that. That means that we are all safe and we can actually celebrate together a new observatory and new eyes to the universe.
Right, exactly. Well, thank you, Stella, for a stellar presentation.
Thank you very much, all. Please be safe.
Okay.
And I hope to talk to you again soon.
All right. Thank you.
Bye.
Thank you.
Thank you, Bill.
All right. I'll record it.